Good morning, everyone. Please have a seat and welcome to the second day of our workshop, ICT for Railways. We have a long list of presentations today, as it was yesterday. By the way, this edition, 8th edition of the workshop, has a record number of presentations. So we have no time to waste. I will be silent and I leave the word to Lola Fernandez, who will moderate this session now, this panel. Okay, thank you.
Thank you, Paolo. Good morning, everybody. So cybersecurity in railways is no longer a future concern, it's a present imperative. Today's speakers will guide us through the evolving standards, regulatory frameworks, and technical innovations shaping safety and resilience of our system. Let's dive into the first half of our panel. Presentations will be delivered one after another, with time for questions at the end, hopefully. And we will start with José Antonio Rodríguez.
Hello, I think everyone knows me. Well, I want to present this presentation about how to deal with cybersecurity in a standard. Well, the real title should be how to deal with cybersecurity requirement in a non-cybersecurity standard without dying in the challenge, without a big knowledge about cybersecurity. As an example, we are going to use the new EN 5463 that we are preparing at the working group 37. It will be ready, I hope, but next year. Well, because the 5463 is a good case, because this standard specifies the requirement of the device on board that must communicate with a system on ground. You have interoperability, you have communication in the middle, you have different agents. It's a good case. You can see here the picture is the same picture they present in the ICT 2015, presenting the development that we've done at this moment. Every security ingredient or the agent around the security is inside this system. How to solve? We solve, because I solved the problem 12 years ago, more or less. Well, was applying the typical schema from the academia. I have Alice, that is DMS. I have Bob, this is the TCS. And also I have the hacker, that's the truly. We must prepare the system for the attack. In this case, for us, the most important was the question of the data, because the energy meter is transmitting to ground the information about the consumption of the train, and with this information we are going to build the billing. And more or less, the billing of the attraction unit could be around 30,000 euros per month, 40,000 euros per month. The data is not correct, we have a problem. Nevertheless, if we have problem with the data, we have an alternative to solve the problem, because we can estimate the consumption of the train. Well, with this idea, I define the part 4 of this standard is dealing with the interoperability, with the protocol for communicating the EMS to the system on ground. I specify that the data, the important data related with the billing, must have mandatory digital signature using RCA ACH 256. is embedded in the data as a part of the XML. Also, if you have problem in the communication between the MS and the DCS, the system in the middle, that is outside of the scope of the standard, we also put as an optional the question of the crypt in the data. Use IS 100 to 28 CTR. We are thinking 14 years ago. The computer power of MS was very small. But now it's a big problem. This algorithm. But also, we not maintain the requirement that appear in the rest of the standard related with cybersecurity, because I think it was 2014, no, Bart? Yes, 2014. You have only mandate for modifying the part 4. The rest of the part must be, I will find. Well, we have cybersecurity requirement in part 1 is no building-related function cannot compromise building-related function. Or in part 4, protect the protection of the exposed port. This is ambiguous requirement. Why? Because if you look in the standard how to implement this requirement, there is no answer. Well, there is an answer. How to test? No, there is an answer. How to measure the test coverage? There is no answer. Only in the standard here, for dealing with the requirement, the phrases should be agreed between supplier and purchaser. Keep the ball. Okay. We received the mandate to prepare the new version with a big complaint about cybersecurity. We want to deal with the question of the ambiguous cybersecurity requirement, with the question that in the protocol we use FTP and HTTP. But the data inside the FTP or HTTP can be encrypted. As you know, you have a system in the middle that the FTP, HTTP say, no, I don't like FTP. And the CISO of the company say, no, I don't like HTTP. Okay, the data is encrypted. You cannot use this data. No, FTP. Well, also, the standard must be compatible with the national and European security regulation. Flexible to adopt new cybersecurity solution and guarantee a minimum interoperability. Well, tool for developing the solution. But we have the ISO standard, the IC standard. I think my colleague Francesco Perotto, who is online, count around more than 1,500 pages to read. Imagine. Well, in the group of developing the new standard, the new edition, every 15 days a meeting about cybersecurity, always with the question how to do. What we are going to, what all the standards say. Fortunately, after 3 months. Odyssey meetings, we found the IC Guide 120, version 2023, that help us to specify guidelines for the inclusion of security, cybersecurity in the standard. And then we find a classification that we have horizontal publication, general, publication related to cybersecurity, cybersecurity publication related to a domain, general, y luego product security publication. Very similar to the safety area. Well, also we study what was doing the rest of standard that was this, with this question. I made this classification. The standard that ran away from the issue. At least they use should in the introduction. The introduction is not a requirement of the standard. For example, the 716 about the requirement for software development in the railway application. In the introduction appear, for cybersecurity, appropriate standards should be applied. It's not a requirement. It's an introduction. Keep the ball. Sorry. The next standard that ran away from the issue, but are really worried. And they use short. For example, this standard about robotics that we did with the question of safety is very recently, the standard 2025. It's a specific clause dedicated to cybersecurity. As cybersecurity, 3 assessments should be conducted. If the cybersecurity 3 assessment identify that 3 can result safety risks, cybersecurity measures shall be provided to prevent unauthorized access. If they give a list of possible solutions. What's the solution? Next, standard. Well, standard really worry about cybersecurity, but not about interoperability, the question of horizontal standard. The other standard, they really worry about ensuring interoperability and cybersecurity, interoperability and security, is horizontal standard in one group and product standard in another group, for example, the FEC. Well, what the AC Guide 120 say about how to include, or is in our standard, we might include the security requirements. He said, if the goal of the standard is a product with a process interface, the standard must follow the rule of a product security publication. Yeah, so we must put cybersecurity inside the standard. Because one of the discussions was no cybersecurity inside. But this is a product. It's a standard for a product. No, because the era, because pretty clean. Sorry for the Spanish name of the company. Say no cybersecurity inside the standard. It's a standard as a product. It must deal with the question of cybersecurity. Well, how to deal with the cybersecurity? Must be clear, consistent, and complete. Omega. We must introduce inside the standard all the cybersecurity requirements with all the details with the algorithm. No. If the interoperability between systems can require that product security publication specific requirement instead of recommendation, can require that products must be inside the standard. So we must use SOAR. When appropriate security considerations should be included in a specific clause in the ASC publication, we must put a specific security clause. Yeah, so security research and technology is developing rapidly. It's a result and application should be reviewed on a regular basis to ensure that it's current with technology and threat in large scale. The standard might be prepared to be outdated. I don't know. Oh my God.
3 minutes.
3 minutes. 3 minutes. Well, how to deal with the development of the standard? To deal with the requirement to be complete. Product security publications should, as far as possible, define the requirement by referring to horizontal publication. So we need to find the correct standard. It's a big job, but less than define algorithm inside the standard. Also, if no specific considerations are necessary for the publication, consider documenting the rationale. Okay. Well, next. Where to put inside the standard the cybersecurity requirement? When we go to the ERC, AC Directive Part 2, and say, general requirement to Part 1. Well, we specify in Part 1 we add a clause related to cybersecurity clause. And the question is priority, because the question of the protocol, we include this question in a specific clause in part 4, in the communication part. As other standard, you see other standard, you see the index appear on a clause dedicated to cybersecurity. In this is example, pues, the manufacturer should declare in the technical data the security measures follow to ensure a secure product. Before this sentence, there is, well, you can use this standard with the 6443 or the 26019, right? Or the 62351. It's a good serious standard related to how to deal with the technically, how to deal with the problem of cybersecurity. Well, with this idea, we introduce in the standard in part 1 a cybersecurity clause with a little literature that they have a standard. You can practice in the standard to other standard, but then the manufacturer should declare in the technical data the cybersecurity measures followed to ensure a secure product. And also we include a note that national and regional regulation can require specific security measures. We are thinking the TSI. We are thinking the ERA. In everything related in part 1, when you have something we're dealing with security, we link to this clause. In part 4, well, the clear requirement for integrity. We are going to use TLS, we are going to use TLS 1.3, we are going to use the 4 condition of the TLS, and also we maintain the question of the creation of the data. Anyone like to also over the application layer to have a more layer of encryption. Here we put over time the note. National regional regulation can require more restricted option. Well, open question. Sorry.
1 minute.
1 minute. So, open question. What standard we are going to use from the horizontal landscape? Because the MS is not a signal device. It's an IT device, it's an OT device, it's an EOT device. If I would like to put in the standard like electromagnetic requirement, you must use this clause or this standard. No more, no less. We have the problem of TLS digital certificate management. We have also the problem of EMS public key management. And we have the problem of cybersecurity patch management. The EMS is moving from one path to another path. Well, conclusion. Now, the new 5463 is ready for dealing with the cybersecurity requirement with the state of the art. You are developing a new standard. Is it a product with exposed port? You must deal with cybersecurity. You must define the integrity in this exposed port. Well, please use TLS 1.3. You are dealing with a communication protocol. Is in the data layer. Cybersecurity is out of the scope. But here you must dealing with a TCP application layer or under is out of the scope of this presentation. Thank you very much.
Thank you. No problem, Serge.
I want to move.
No, it is not this one.
Not this one.
Serge. Después de la tuya.
Sorry.
Okay. Yeah. Thank you. So, okay, it works. Good. So I'm Serge Benoliel. I work in Alstom, and I'm in charge in Alstom of cybersecurity governance and expertise for the security of product. And I am also a role of project team leader of the IEC project team 63452, which aims to develop a cybersecurity standard related to railway. During this presentation, I will quickly explain what is 63452, what is its purpose, who are the people who are working on this standard, and a very quick overview on the standard itself, and after a conclusion. So first point, the 63452 is a vertical railway standard. So it is based on the adaptation of the 62443 in the railway context, and its scope is the whole railway systems. So that means trackside equipment, rolling stock, signaling system, control center. It means freight train, high-speed train, tramway, metro, etc. So really everything which is on rail. So it's very large standard, and that means that it's more, it will address topic as governance, as how we should manage cybersecurity at system level for an operator or for a system integrator mainly, and then indirectly product supplier and I will say maintenance service provider, etc. will be impacted by the standard. The main focus is railway application at operator level and system integrator level. So it covers the whole life cycle. So that means from initial ID inception till the development of the railway application, and then the phase of operation and maintenance and disposal. One key target for this standard is to align expectation between main railway stakeholder, that means asset owner, system integrator, maintenance service provider, product supplier, and to create a common language in order that they have all the they share the same expectation and all over the globe. Another thing which explain, I will say the number of page, is to bridge expertise between cybersecurity guy and railway guy. Up to now, we have a few people in the, I will say, in the railway community, which are both expert on cybersecurity and on railway. So that means that there is a lot of guidance and explanation and informative stuff, which allow, for example, a cybersecurity expert coming from the IT world to well understand what are the railway specificities, and same thing, an engineer, a system engineer coming from the railway to well understand what are the cybersecurity needs and way of working, etc. So this was also an important main target for the team. Important note, the product levels, that means equipment and devices, are voluntarily out of scope of the standard because it was considered from the start that we want to be able, do not want to add specificities from railway on product which can follow, for example, the 62443, so industrial product, or product if you buy firewall appliance, perhaps it will be follow the common criteria, etc. So we want to not add complexity at the equipment and device level, and so the standard position itself at system level and governance level and general way of working. Another important note is that it takes into input the work from CNLEC, so the TS 5701. I was part, in fact, of TS 5701 work group, so it was the work group 26, and I was secretary of this work group, and which produced this. And for the story, when the TS was issued, we considered that it was important to propose it at IEC level. So it was, and because there is several good points into it, and the EROPA wanted to make sure that there is no concurrent initiative which could jeopardize the standard, etc. So we were proactive, and it's one of the first time that the TS, European TS, can become, it's not made yet, but can become directly an IEC standard. Usually a TS become an EN, and after the EN, sometimes it become an IEC standard. So this is also rather exceptional. The team. So the team, we have 4 continents, 20 countries representative. We have a strong representativity of the railway sector. We have railway operator from Europa, but also from US, from Japan, from China. We have all the big system integrators, all the big manufacturers, several big product suppliers. There is also cybersecurity solution providers which are part of the group, which are strongly contribute. All these guys are strongly contributing. And also we have link with UITP, and Europa we have strong link with ERA and ENISA. And for example, we will have our next workshop in December, which will be hosted by ENISA on ENISA premises. And we are working with them on some analyzing the impact of European regulation, for example. There are usually 60 people which are working, attending to the hybrid workshop, either remotely or in presence. And there is up to now 148 registered members. They do not all participate, but it demonstrates the interest of the railway community to this standard. In order to be also to work, we divided the work in subgroups. So every subgroup has a part of the standard, and we have periodically, every 2 months, workshop of 3 days to align the subgroup and to solve issues which cannot be solved at subgroup level to achieve a global consensus. The timeline, this work on the 6352 started in summer 2022. First draft 1 year after was delivered in August 23. We received a lot of comments, 3,000 comments, some duplicates, but okay. And we achieved to provide the CDV, so committee draft for vote, in March-April 25. And the EAC start the inquiry in August. And the inquiry, now we are in committing phase of the CDV, and we should have at end of October the result of the vote of National Committee. If the vote is positive, we will go through to deliver the final draft for international standard. So between the result of the vote, between the CDV and FDIS, we can take into account technical comment. So according to the number of technical comments, perhaps we will be more or less around February, so it will depend. And if we succeed to deliver the FDIS for February, we should have the international standard published this summer. So on the CDV, what is important, because it's rather mature, CDV is a state which is mature. So we have one thing, which is we have a short number of requirements. So even if there is a lot of pages, the requirement we have today, I think it will increase according to the comment I've already seen, but we have 70 formal requirements with shall. Each of these requirements have an identifier, and each of these requirements have associated guidance, etc. So it's very easy, and it was a focus, I would say, a target for the group to provide a standard which is usable and easy usable. So it's easy to extract in a simple table all these requirements, and all these requirements follow a template where you have a responsible of the requirements, the action to be done, and the thing concerning by the requirement. So it's why it's written carefully crafted requirement. It was one of the good improvement between the CD and the CDV, the work on the requirement. 265 pages of total, so it seems a lot, but on these pages, 80 pages are the core of of standards, which correspond to the 70 formal requirements, and the rest are informative stuff, guidance, etc. We gather key concepts from, of course, IEC 62443, risk assessment, security level, cybersecurity requirement. From the, I will say, RAMS life cycle, we take also some concept. We map the RAMS life cycle versus cybersecurity activity. We take the concept of threat logs. We adapt the concept of safety case for cybersecurity case, the demonstration that we achieve the adequate level of cybersecurity, and the notion of SRAC has been adopted as SICRAC, so exported constraint to be respected by the operator and the maintainer to ensure the security, the maintenance of the security of his railway application. Some also, in the standard, I said we try to address and to provide content specific to the railway sector. So there is in clause 4 example of railway system modeling and zoning in order to know the context in which a new railway application can be inserted. And in that, in fact, in clause 4 also, we take some input from ERGU. I forgot ERGU as a point of synchronization. For example, the concept of shared security services have been integrated in the standard to say, okay, when you have a railway system, it's good to have a shared security service which can provide a shared security service to the different railway applications. Mapping of cybersecurity activity versus RAMS lifecycle. So this is important to ease the integration of cybersecurity when developing a new system. It's a point which have been, I will say, submitted some hot discussion lately. Okay, was the flexibility of requirement. So in fact, according the country, according the sector, for example, urban versus mainline, there is different way of working and share of work between operator and system integrator. So because of that, some requirements are flexible, and you say, okay, when you start the project, you need to decide the share of work between system integrator and integrator. A typical example is the risk assessment. On some on the world, the risk assessment and we'll say the associated security requirements are defined by the operator, so that's a fact. And on some, the operator don't want to do it and say to the system integrator, please provide me a railway application and perform risk assessment. I will just validate the risk acceptance criteria. So the standard is flexible and allowed to work on these two ways. In the annex, as you have understood, the standard don't provide detailed technical requirement on every subsystem. It's just impossible because we cover all the system. We have ambitions to cover all the system. But nevertheless, in the annex, we provide guidance on the 62443-3 requirement. So that means how to interpret these requirements, which are, I think, very relevant, and how to interpret these requirements or implement these requirements on a railway system. So this is rather interesting. Okay, I will be quick. Clause 10 provides a lot of stuff established by the railway operator about operational maintenance and disposal requirements. And we have also addressed cybersecurity and safety interface, the legacy system, and some topics which are new, how to provide a secure cloud for OT cybersecurity. Here it is, I will let you read the slide afterwards. It is the overall structure of the standard, and you see clause 4, clause 5, clause 6, clause 7 is related to risk assessment, and you have a main topic in each box of a global clause. Clause 8 related to requirement, clause 9 to security assessment, and clause 10 related to what you do during operational maintenance phase. So a clause very important for anyone who wants to perform railway operation or maintenance. And after a lot of annexes. Example of railway model, topological model provided in clause 4, so you have over. Example of the requirement extract where we have, you can see in the various colors, the various way to write the requirement with a subject, a shall, the topic, the object of the requirement. And in conclusion, I will say that this standard, if it is approved, will bring a global common language to the railway sector for cybersecurity. We think we achieved an efficient and consistent requirement, which are not too much. We provide a tailored adaptation of 62443 for the railway sector, respecting the main concept of 62443. There is things related to RAMs and safety integration. There is a clear role and collaboration which are explained between to align expectation between asset owners, system integrator, etc., and a lot of guidance and support in the annexes, and that's it. One last point is for the European level. We have also a work ongoing so the IEC 63452, if it is published, will be replace the current TS 5701, and we are working to either it will be an update of the TS 5701. There is some recent discussion about that, or an appendix to the 63452. We are working to complement guidance, European guidance, which will explain how the 63452 could support NIS2 and Sierra compliance. For example, Sierra compliance, if a train is considered as a product with digital element, the train can be submitted to the 63452. So we want to explain, okay, how the 63452 can support Sierra compliance, and same thing for the NIS2 for the railway operation on the OT world. And I have finished.
Thank you, sir. Alonso, please.
Hello, good morning. So I'm Alonso Martinez. I work at Moxa as a rail application manager. I have experience in over 20 years in railway, developing and design systems like TCMS, passenger information system, event recorder, CCTV, and of course communication products. I am also part of the ICT 9 working group 43, working on the 6175 standard that is for the train communication system. Also, today I'm going to talk about my daily work, and I'm going to share my experience with the 62443 standard. So for that, as Jose Antonio said, that is this standard is this standard, and also this the regulation is 1,000 of pages. So I will try to change your mind, and you see that is a powerful tool in order to comply with this regulation. So first of all, I'm going to talk about I'm going to give a brief overview about the NIS2 and CRA. NIS2 is Network and Information Security. It's an European directive. That means that all European countries need to adapt this directive to its national standards. So this is begun in last year, in October 2024. Also, there are some countries that they have not, or they are still implementing this directive. It's targeted to important and essential entities. It means like entities that work in sectors like energy or transport, obviously railway too. And the objectives are strengthen cybersecurity resilience and preparedness, harmonize security measures and supply chain protection, and improve incident and reporting. On the other hand, CRA, Cyber Resilience Act, it's a regulation. It means that it can be applied directly. So European Union countries doesn't need to modify this regulation. It began in 2025, but it's mandatory in 2027. It's applied on all hardware and software digital products. So as Sergi say, even probably in the future to trains. And the objective is secure by design the product, is CE marking for cybersecurity, vulnerability management and updates, and adopt a life cycle approach to cybersecurity. So basically, we could say that NIST apply to entities and all his process, and CRA apply to products and his life cycle. So we we try to move from objective to practice. We need to fix or to analyze the Article 21 that translate. This is the core of this directive, and translate objective into concrete cybersecurity measures. So I have divided all the measures in the three goals that I explained before. So for cyber resilience and preparedness, is risk analysis, cryptography, effective assessment, and training. So in the case of the security measure and supply protection, the measures are supply chain security, vulnerability handling, disclose, access control, and multi-factor authentication. So in the case of the improved incident and reporting and response, incident handling, disaster recovery, just in case there is a fail, and emergency communication. So this seems that it could be a checklist, but that is to put into practice all the cybersecurity in the entities. So that is the reason, because it's important, this directive. So in the case of the CRI, as I said before, this is applied to products and basically to the entire life cycle. So for that here, I try to represent a life cycle of the product, a very basic. So it's basically to design the product, secure by design the product. It's important supplier due diligence, and we will explain later. Also, when we want to put the product in the market, it's necessary to audit certification to get the CE marking. So also quite important. Later, we will continue with the vulnerability management and update. So this gives the meaning of continuity. We need to report the vulnerabilities and to share the software bill of material and its regular updates. And of course, ongoing. This is a cycle right now. So here, this regulation demand a very high level of cybersecurity, but also provide a very good process for the companies or for the development of the product. And now, that is the powerful tool for this or for comply. So this the IC 62443, probably all of us, we already know. Also Sergi has explained a little bit about that. So it's a standard family for industrial automation control system. It's very wide standard. It's covered policies, processes, technical control, and product life cycle. It's very well recognized, and is divided in different parts. But we are going to focus only on components. Why? So first, because Moxa developed product, so it's simple. If we are expert in components, I'm not going to talk about other parts, but also because it's compatible with the next standard that Sergi explained, the 63452. So this part is a certifiable standard. It means that companies that want to develop secure product following this part need to get the certification. In the case of Moxa, it was one of the first companies in railway that get this certification and certify the life cycle development for the product, and also it's necessary to certify the product once you finalize, and also Moxa has certifying on those of products. So that is because we consider that this part is the most important to continue talking about this in this presentation. And what is that? So, as I said, Moxa got the certification for his development life cycle some years ago. And this is basically the scheme of how we develop our project is based on the usual V life cycle, but there is adding some important parts. So the first one is the supplier onboarding. That is the first stage, where it's quite important that the software-bound tracking, in order to get transparency between all the suppliers that integrate or participate in the development of the product. So also companies, or Moxa in this case, need to manage the threat, or the next step is the threat intelligence, is try to understand the threat landscape and to know where this product is, the context where the products are going to be installed. So also the next step that will be threat modeling, is secure by design. Also continuing in the development with the software security risks and assessment. And here what is important is to know if there is any risks, to define the mitigation and implement it. So that is quite important, because there will be new requirements for our product. So the next step that will be security tests. This is not only the usual pen test or that everyone knows, or the vulnerability test, is also to verify that all the mitigation has been very well implemented. Finally, what is also important stakeholder is our customers, because they need to receive the vulnerability reporting, they need to provide the guidance, and they need to be in charge to patch the vulnerabilities. And finally, the last point is the authorities that is necessary to report. Pay attention to this last stage, because we will talk later. And all together, all suppliers, developers, customers, and authorities need to see this product life cycle like a closed loop that is need to be analyzed, to do the assessment, to monitor, and to update continuously. So that is the most important part. And the next one is the part that's 4.2. That is developed by cross-industry collaboration and best practice. So it's matched very well with the future railway standard. So it's defined over 120 requirements. It's divided in 7 areas, and as all of you know, is depend of the security that is needed at different levels: SL1, SL2, SL3, SL4. So it provides a baseline for compliance and product certification. That's mentioned again that it was a certificable standard. And it's regularly updated, or that is the intention, to regularly update and to reflect threats, technologies, etc. So these are the 7 fundamental requirements. That are the block: identification, authentication control, use control, system integrity, data consistency, restricted data flow, timely respond to events, and resource availability. Here are all those requirements that are related with authentication, with encryption, system log reporting, so on. So all those information, all those requirements are included there, and depend on your product, you need to comply or will include it and comply or not, and later at system level that we decide how to apply those requirements. So here, what I try to represent is how match NIS2 and CRA with the 62443 in the part that we are focused, that's 4-1, that's 4-1 and that's 4-2. So basically, it's possible to comply with all security topics, except with the one that I mentioned before. So that is the information sharing with authorities. So that is part that is need to be done in other levels. And also companies need to include it is its own development life cycle. As I saw before, in the last stage, it was to report to final the authorities. And finally, the takeaway, that would be from regulation to peace of mind. Why? So we consider that NIS and CRA define what is necessary to comply. In this case, NIS2 is resilient, reporting, supplies, or are the goals that we commented before. CRA, secure by design, vulnerability management. The IEC 62443 define how it's necessary to do it in order to that our customers has a peace of mind. So they have a secure product, later secure system, and what is more important, to have a secure reputation. So that is the final goal. So thank you very much.
Okay, next the speaker is Markus.
So, I'm Markus Fischi. I will talk about what the EU Rail system pillar is doing for cybersecurity. I'm now with Siemens since 25 years, 9 years with Siemens Mobility, working on security with a lot of people that are technical in security. We started with Shift to Rail, where we got all the operators and the industry together. I'm heading the UNIS6 Cybersecurity Working Group, so responsible for the subset 146 for ETCS, and we have a talk about this topic, I think, in the next panel. And I'm also leading the system pillar cybersecurity domain. And I think I can bring a lot of things that was discussed this morning together, how we do it actually practically. So I'll talk about our workflow, our cybersecurity architecture, which is generic and applied to many different parts, our taxonomy and our specification details. So we wanted to be not only from a system pillar, which is this generic system integrator, we said from our domain, and the cybersecurity domain is one of 40 different domains. There are actually 500 people working in the system pillar, and we are 14 people in the cybersecurity part, 7 from the industry, 7 from the operators. We want to mitigate the security risk by defining requirements for the rail cybersecurity in the scope of the system pillar, which is a quite large scope of the rail system, to support the interoperability across Europe, reduce the life cycle cost, and support a unified market for components in the railway system. So we want to drive down the cost of implementing cybersecurity. How do we do this? So when we started about 3 years ago in the system pillar, we looked at 42 documents about rail and cybersecurity. So this is, I mean, everybody thought about cybersecurity already 3 years ago. Everybody published something, in total 42 documents about cybersecurity. And to get everybody online on the same page, we actually made an assessment. The assessment is also available if somebody still wants to read it, but we condensed from all these input from Shift to Rail, from UNISIC, from ULINX, from ERTMS user group, ENISA, Okora, the different parts, and created a common specification, a technical specification for interoperability. And this was now published in May. We are not only working in the cybersecurity domain, we have also mirror groups. Lola here is actually one of the mirror groups, so we have an extended part not only from the industry but also from the operators, the ERTMS user group. The RSAG is part of this mirror group, so we have a much wider audience for reviews. What's really important, what we did is the 4 main specification, the secure component specification that has technical requirements on the components, which are not interoperability related. I'll come to this later. And we have 2 specifications which are related to interoperability in the rail domain. One was mentioned already by Serge, this shared cybersecurity service, an infrastructure for PKI log and time synchronization and identity and access management, where we want to have a common set of interfaces in Europe for the rail domain. So that when we build products, we know regardless where we ship it and in which domain we can connect to the same services. So we have the same PKI management, we have the same log interface wherever we go in France, in Switzerland, Germany, Spain. The same happens for the secure communication specification. So this is a secure definition for different security protocols, TLS. As was mentioned here by José, how we actually should communicate, for example, from EMS to a DCS or from an onboard unit to an LPC. This is subset 146. And we've just harmonized this. It makes it also easier, less costly to implement. And lastly, we have the secure program requirements, which is an implementation of the 62443-2-1 and ISO 27001, how to actually operate a secure system, mainly for the asset managers. One thing is actually what we also met is complete compliance mapping to these specifications, to all these existing European legislation. You heard it before, we have a couple of European regulations, the NIS2, the Cybersecurity Act, the Cyber Resilience Act, the Radio Equipment Directive, but also international standards like the one for ISO 27K, the 62443 that was in the previous talk, and the one that was Serge presenting, the TS 5701 and the 63452. So when you do these four specifications, you're in compliance with most of the requirements from these ones. So it's a super easy help for the industry and for the operators. And it has been adopted already by quite a lot of organizations, and I come to this. So what are the benefits for the operators? It's compliance to the relevant security legislation and standards, the same for the suppliers. We have an increased choice of compatible product because it's a standard. And on the suppliers, we have less complex products because we don't need a French security version, we don't need a Swiss security version, we just have one for Europe. So it means a lower cost of product and system. And for operators, it also can be used as a reference system that makes the application of the TS 5701 and the 63452 much easier. How do we actually map it and make it applicable to any system in the rail domain? We defined the generic architecture, which is just saying we have secure components, A and B, and they need to talk. Now, could be in the telematics part, could be in the CCS part, could be in the EMS part. We need to ensure that they communicate securely and they can adapt to or communicate to the shared security services, which we assume will be established everywhere in Europe. And this can be mapped into any architecture. We have here a CCS architecture, that's the more traditional one, with an interlocking RBC, TMS, and onboard units. We have on the top layer the shared security services, and on the top the integration into the back office systems. And we can map this to another one. This is the system pillar one, where we have a different setup, where we split the interlocking, it doesn't matter. For us, all the blue components are secure components. So the generic architecture, as we use it, when I come to the generic architecture works. So this is how we actually set it up. So as I said, we have secure components. It needs to talk to another secure component. We have the secure communication specification for this. Both of them talk to the shared cybersecurity services. We have an interface specification to all of these services. For each of the components, if they want to comply to CRA and to 62443, we have the secure component specification to comply to this on a technical level. And to operate it, we have the secure program requirements. And that makes then the compliance to the NIS2, to the different standards that have process requirements. We have also not only these 4 specifications, we have 7 supporting documents. Here are the 6 ones. We have the regularity compliance is basically the tracing tables that we have to all of the cybersecurity legislation. So an exact tracing, how we fulfill NIS2, how we fulfill the Cyber Resilience Act, and how we fulfill the international standards. Especially for the 5701 and the 63452, we provided additional material to enable an easy application of these standards. The support of essential function is a list, a system description, we have a threat catalog, we have an initial risk assessment, soon a detailed risk assessment in the next version, and we have a product documentation template that's quite important for the Cyber Resilience Act. And this is, takes all the requirements, not only from the Cyber Resilience Act, but also from the 62443/4-1, because this has also documentation requirements, and the 62443/2-4, the 5701, and even the 63452 has documentation requirements. And we put this all in one template, and this template, when you do it, fulfills all of them. So people really like this because it simplifies to be compliant to what's required. How did we actually get to this? We made 3 reviews starting from February 2024 last year. We had the first review, we had then made a second review, and these were wider reviews. So we basically made it open available on the web page so that everybody who wants to look at it could actually give comments to. The last comment round was then in December for the final review, again open for all people in Europe to participate, and then in March we could actually publish our first version. It's downloadable, there will be a CR, this code will be also displayed bigger in the end. We are currently in the maintenance phase. So we are actively looking for feedback. We're planning a new version in 1.1 in March. So we're closing the comments basically this month. So whatever want to become a part of this error correction release in March needs to be submitted by end of this month. We have an email address where these comments can be sent to. We will not stop accepting comments, but it will not come to the 1.1. It will come then to a year later to the 1.2. One very interesting aspect was that we were contacted by ERA to analyze all the TSIs and to create comments and close the security gaps in these TSIs. The most pressing one at this time was the telemech TSIs, where we have constantly giving feedback. And we had started all in February actually this year, because after we published our specification, we looked at all the TSIs and made the analysis. So what was the result of this analysis? We identified quite a lot of TSIs which didn't have any communication requirements, so noise, the wagon, infrastructure and tunnels didn't have any technical specification for communication, but CCS, telematics, energy, which also Antonio just presented, had these technical interfaces, communication interfaces, and there's OPE and lock and pass where we still want to have to analyze the specifics. So with telematics, we have been very successful. They actually reference the system pillar specification. And we are in constant discussion here with Bart and Jose to also enable the energy to get to the same level. The way we want actually to do it, and this is also what ERA wants, is to have a harmonized cybersecurity implementation in Europe. So we don't want that every single system defines their own requirements, because then when you want to operate, for example, a train, and you have every system defining its own cybersecurity technical requirements, then it becomes more complicated. One example is that In the signaling part, the ciphers that are defined are ECC-based, and we just heard that in EMS it's RSA. So it means another PKI hierarchy. And this is what we, when we do standards, can easily avoid by just referencing to a common set of standards. And that's what we're proposing and trying to establish in Europe. Last slide, just on the outlook, what we are doing, we are not talking only about specification, we're talking about now to implement the whole thing, to get it practical hands-on knowledge. We have now, in the tender that comes out next week, a technical enabler for cybersecurity. It will be a demonstrator setting up all these shared cybersecurity services that you see, time, PKI, log, IAM, and so on. When we get then over the next years some findings about these demonstrators, the feedback will be fed into the system pillar. So this is in the innovation pillar. We heard yesterday from Nicola what the innovation pillar is. It's really building these technical enablers and then demonstrators. And we make this available to all the other demonstrators so that FRMCS can use it, that Digital Automatic Coupling can use it. So it's an easy way, it's a cloud environment where people can get time synchronization, where they can get the PKI certificates, sending security logs, and so on. So this is an interesting thing that will start in next September. And that's it from the EU Rail Cybersecurity. Thanks.
Okay, and our last speaker of this session, Diego.
How can change this?
You have
I see. Okay, good morning. I'm Diego Gervasio. I've been working for Hitachi Rail since 2016 in System Safety and RAM department. Nowadays, I'm RAM signaling integrator for 3 metro projects. The revamping of Metro Bruxelles, Thessaloniki Metro that is in revenue service since last November, and extension to Calamaria. As we discussed in particular yesterday morning, the railway sector is a critical infrastructure for the transportation of people and goods, and it requires high safety and reliability standard. The increasing complexity of the railway system related to introduction of new technologies of the automation some process has made the research of new methodologies for the risk assessment very essential. But what is the risk assessment? Risk assessment is a systematic approach that identify, analyze, and mitigate hazards that could compromise the safety of the people. As we can see later, this hazard could derive from technical failure, human error, or environmental factor. In the recent year, the risk assessment has been made more difficult after the introduction of new technologies, because on one side it improves, for example, the digitalization, it improves the operational efficiencies, but on the other side, it introduced new vulnerability. For example, in the last presentation, we see cybersecurity attack, cybersecurity problem. We can have programming error, but also we can have human error that are related to more sophisticated interaction between the operator and the new system. So the human factor remains critically because influence the safety through decision, risk perception, and to respect the procedure. To understanding, so the human error is very crucial to increase the safety and the reliability of a metro system. The risk assessment include, of course, the hazard analysis. The hazard analysis starts from a system definition, is the source of the hazard. There is a process to process to identify the scenario, so the hazard. We can specify where the hazard is applicable in terms of location, for example, in main line, in depot. We can specify if the hazard is related to a driverless metro, so without driver, or is for a Go-to project, for example. And of course, we have to identify which are the consequences of the hazard. For each hazard is identified a set of mitigation, and is calculated the pre-mitigation risk assessment and the post-mitigation risk assessment. The hazard is managed until it is eliminated, or it can be considered acceptable in terms of risk. Risk is the combination of the failure, the frequency, and the consequence of the hazard. And this process continues still the risk is considered acceptable. When the mitigation is identified, this mitigation could be traced to the requirement or can become a safety-related application condition that could be exported to the operator or added in installation manual or in maintenance manual. I would like to highlight that in Hitachi we use a unique tool to manage the safety activities, but also the requirement management and also the validation and verification activities. Maybe later I can come again on this point. It's important to analyze different types of hazard source. We have the systematic failure that could derive, for example, from design error. We have random failure that could be from component. We have human error that are all the hazards related to human and could be related to cognitive overload, to bad training, to procedures that are ambiguous. And at the end we have environmental or operational issue, and so external factor that could be extreme weather condition, compatibility interference, or vibration. In the system, in risk management, we can combine qualitative and quantitative method to analyze. For systematic failure, usually we use qualitative or semi-quantitative method, failure mode effective analysis, for example. For random failure, we use quantitative method, for example, fault tree analysis. I will skip human error. For environmental operational issues, we have combination of probabilistic and scenario-based analysis. But what about human error? For human error, we need specific techniques because it's a multidisciplinary field that involves psychology, medicine, engineering skill. So it's more difficult than the other failure. To better understand the human error and try to mitigate, we can consider this process, the array process, that is the only one that has been developed specifically for railway domain. The acronym is Railway Action Reliability Assessment. It has been developed by an independent organization that is Rail Safety and Standard Board. And the object is to improve the safety and reliability of the system through the assessment and the mitigation of the human error. Let's analyze in detail the process. The process starts with the definition of a task. So we have to analyze which are the tasks that the operator could perform. Operator could be the driver, could be a maintenance, could be a supervisor, could be a train dispatcher. And the output instead is the human error probability. So the probability that the operator make an error while performing this task. There are processes allow us start to assign this task to a set of 8 generic tasks called the generic task type. There are 8 categories that could range for a simple task, a complicated task, or those actions that, for example, should be performed during an emergency situation. So once the analysts have associated the task to one of the 8 generic tasks, he have to choose a probability. The RARA process gives a range of probability. The analysts have to change a value inside this range. It is not very easy, this step. Then we have to individuate what is called error-producing condition. There are the degrading factor that compromise the task. So are environmental or situation factor that can increase the probability of a human error. The final result is the human error probability that could be obtained combining the frequency of the generic task type and all the error producing conditions chosen related to this task. Which are the advantages of this process? Of course, it's widely used and is accepted, especially the only one that has been developed for the railway domain. Its reliability, so we provide an accurate assessment of human performance, and also it's flexible because you can adapt to different situations. The 8 generic task type cover almost all the tasks that usually are performed in the railway system. But of course there are disadvantages. The most fundamental are the subjectivities of the analysis. As said before, the analyst should choose a value inside the range of frequency for the generic task. The range would be also starting from 10 minus 5 to 10 minus 2, so it's a big range, and this can introduce subjectivities in the analysis. The second disadvantage is that often, since it's quite complex, this analysis is using a simplified version of the process, and this can often lead to extremely conservative result. To overcome these advantages and preserve all the advantages of the RARA process, has been introduced the fuzzy RARA process. A quick overview on fuzzy logic is a mathematical network that extends the Boolean logic. It relies on specific rules called membership function, so we assign gradual true value between 0 and 1, so a real number. So not be true or false, or we assign a value between 0 and 1. For example, you cannot say the driver is trained or is not trained. The driver is well trained, for example. And okay, there is flexible human-like reasoning, so you can use this framework when the Boolean logic is not enough. Okay, this is the picture for the RARA process. I don't want to annoy you to all the mathematical concept behind, so the calculation of the area of the trapezoidal and so on. What is important to say that the fuzzy is used in the preliminary phase of the process and in the last phase. The process called fuzzification, so help the analyst to choose the exact value for the frequency of the generic task type and for a PC using a linguistic variables, so words, no more true or false or number, but you can use linguistic variables. As you can see, there are many steps, demanding steps that involving very complex mathematical computation and so on. So for this reason, we developed a tool that allows the analyst to choose the right generic task type and suggesting some example which could be the most appropriate generic task, and of course automatically made all the computation needed. This tool developed has been integrated in our environment. You can see the advantages of having in one unique place, unique tool, all what you need for the risk assessment, so you can evaluate the mitigation that are functional, so are directly related to a requirement, so are implemented through a software, but also you can consider which are the procedural mitigation, and of course you can take into account the human error to perform this procedure. Again, this is all in a unique tool. Conclusion, 1 minute missing, I know. Okay, so the human factor remains a critical element for railway safety, even if has been introduced advanced technologies and all the system has been automated. To overcome and to better analyze the human factor, we consider the RARA method. The RARA method has been improved with the fuzzy logic, and we can reduce the subjectivities in the evaluation of the analysis for human error, and we have developed this tool that in a unique one place allow you to calculate the risk assessment combining procedural mitigation, mitigation, functional mitigation. Okay.
Thank you.
Thank you.
Okay, so we are very well on time. So we have almost 20 minutes for questions. So is there any question in the audience? Yeah, but Jose Antonio, maybe.
Yeah.
The question mark.
The question is for you.
No, I hope no.
Well, yeah, I know.
So question is to Jose Antonio Marcus. Older one?
No?
Ah, that works.
Is he ready?
Yes. So question is to Jose Antonio Marcus, but also Denis.
No very difficult, please.
So we might be able to refer to specs of system pillar, but as you mentioned, they will change every year. So it can't be a normative reference, because it should be to the latest ones. And then also a related question to Denis. How do you think a Senelec standard can refer to a document of system pillar of Europe's rail, but system pillar Europe's rail, a few years ago it was shift to rail 2, before it was shift to rail. How will it become something on an official level, or will it be something offered to a standardization body? But then it's again a question to Marcus, so it's a question to the three concerned parties.
Yeah, maybe. So thanks, Bart, for this question. We are well aware that the system pillar is a project, and to make a reference from an EN standard, this is probably not possible. There's of course things that you can just copy certain things, and but we're working with ERA to make these specifications as ERA technical documents, and then it might be easier to reference them directly. For the variability, we're making baselines. So as every standard, we will make one version and have another version in an update version with a dedicated reference. So when you make a reference to a dedicated version, it stays stable. It doesn't change.
Yes, if I may. Regarding the standard, yes, of course, standard should refer to stabilized document in general. Standard also. Okay, so maybe the point is why, because there are some, and yesterday we have the presentation from Nicolas Furio about the STIP and the relation between research and standardization. So maybe the question is, why cannot we transform this document into a standard? Because the good benefits of a standard is that it is submitted to a certain process, it is validated by national committees, and it leads to a very stabilized document that can be referred by other standards. But for the moment, yes, of course, I understand the issue that you have, that you cannot refer to this document because it is in the rule of Sense and Elect not to refer to a document that is not part of a standard.
From the point of view of Part 4, we move and we put in the Part 4 we have the cybersecurity class for interoperability. This standard is going to be used by the TSI, and the TSI can say, we apply everything except this cybersecurity clause because we are going to provide a more stricter requirement. But everything, the rest of the standard is going to work well without problem, because we concentrate in this cybersecurity part, everything, and don't affect the rest of the standard. Thank you to the modeling of the standard using layers.
So I can tell you how it works on the TSI telematics and the TSI CCS, because here we see also the reference. They use actually the references. It's not an EN standard how they write it. They write it as a technical document, and in the CCS it's Unisys subsets. In EMS we have an EN, but as Jose just mentioned, the TSI text can, and that was ERA was hinting to, if the EN is not going into its direction, it will just override it in the TSI and say the cybersecurity requirements in the EN will be not valid. It will be a reference to what is published by the system pillar, or then as a ERA technical document. So ERA is really wanting to harmonize the cybersecurity for rail. And if the EN is not following this, then there will be an overwriting in the TSI text.
Also, this standard is not only for train moving from one country to another country. It's also for tram. It's also for tramway. They can use this standard. It's out of the scope of the TSI.
Yes, we should not forget that the Commission is requesting the agency to have less regulation, I would say, but more referencing to standards. So we have to keep that in mind also.
I think we have a question in the back. Yeah.
It's working. Yeah, there we go. So thank you very much. It's very interesting to see a talk from reliability point of view and then talks about cybersecurity. I'd be interested from, I don't know who in the panel might like to answer, but that the relationship between those two is a very interesting thing. For example, many times if you have a cybersecurity problem, you'd want to shut something down. Sometimes that meets reliability issues as well, but sometimes there may be a tension between those two. I wonder whether how much dialogue and conversation there is about that potential tension in the standards and other work.
Okay, who wants to answer? Maybe you search this interface between safety and security.
Yeah. So in the current draft, there is a chapter dedicated for the interface between cybersecurity and, I will say, over-engineering discipline as safety and RAM, reliability, availability, maintainability. Today, so there is some requirement about this discipline need to talk together, and some guidance on what are the typical output you need to exchange between cybersecurity and safety, things like that. So this is considered. We receive a comment, I think, between this version of the draft and the FDIS, we will amplify a bit the part related to reliability. Because indeed, cybersecurity measure can hurt reliability. If you cut a communication network, we will have an issue of service level. So we might improve that a bit in the final draft. For now, the communication, the interface is more, we really focus on more on safety and cyber. This was a lot of discussion on that because one key point is that if you don't segregate intelligently, I will say, cybersecurity and safety, you end up with safety system where cybersecurity defenses are embedded in, and if you want to update, a system is secure only if it is updatable, the security defense are updatable, and if when you modify the security barrier, defense, whatever, it triggers an update of a cybersecurity case, we have a big issue in the railway. So the focus is, okay, the two need to be coordinated because cybersecurity need to protect safety, for sure. So there is a coordination, but after in the implementation, we need a segregation in order that the cybersecurity world can evolve at its own rate, which is very frequent, each new vulnerability, without impacting the safety case and the safety principle.
We continue to work that from the 63452 that Serge just explained, also on the system pillar cybersecurity specification. As we are a reference system to the standard, we listed all the security requirements that might have an impact on the essential functions. So, of course, cybersecurity has access restrictions, has the software update topic. To all of these security measures that have an effect on essential functions, means safety, we listed them and we showed them how we mitigated or reduced the impact on availability or reliability. So this is one of the supporting documents, and it's a very good list. It's about, I think, 20 requirements, and you see all the mitigations in the processes. Yeah, if you don't renew your certificates, the whole system will stop. And therefore, we have in the process requirements for the operation of the system, we have a requirement that you need to take care of this. So that the combination of the four documents are really well tied, that we address especially the problems that we have in industrial automation system in the rail, because availability is a must.
I also for the answer when we are looking for what other standard was doing with the cybersecurity requirement, we discovered that the standard for developing software for safety system don't run away with the question of the cybersecurity. Safety standard is not dealing with cybersecurity. I don't know if in the next revision of this standard must be translate this requirement from the introduction. No, this is not a requirement. Must be translate from introduction to a real clause inside the standard. It's safety.
Any other question? Yeah, here.
Hello. Yeah. So a question for José Antonio and a little bit for Serge as well. I saw in your presentation in the new version of the standard, you are really going very detailed technically on the cryptographic primitives to be used there. And it's not very common to find this in standards, this level of detail, because it brings some benefits of setting up a minimum level of security, but also very strong constraints for the manufacturers and the parties implementing that. So what's the reason of having this approach and not having an approach setting it as an example and allowing other primitives that are at the same level of security? And then the second part for search, do you envision to reach this level of detail in future versions of the IC? Thank you.
Well, the reason was the interoperability, because the EMS is from one supplier, the DCA or the system on ground are for other suppliers. You must guarantee that in the virtual and the commissioning, everything working well from the beginning. This is the real reason. Also, you think, well, when we developed the standard, so the part for the standard 15 years ago, we don't have CT443 or the standard only the FEC. Well, this schema of Alice, Bob, and Trudy, I try to do the best in this moment. But now it's working. We have here the example of Adia, or also Francesco is online, can tell us speaking about this interpreter is working with a little tuning, because we standardize to the port of the EMS. Inside the EMS to the port of the EMS. And we are standardized from the port of the DCS to inside. We don't standardize the system in the middle. What's the problem of FTP, HTTP? Yes. Okay.
Yeah, to answer to your question, so this we have several ideas to go on the work after the first publication of C3452, and one of these ideas could be indeed to issue some, I will say, a protection profile or a set of technical requirements. We will target a specific domain or specific subsystem, etc. By the way, the input from ERGU could be, if we an input for this type of work. So I think carefully chosen because it's an IEC, so it's a global standard, so it's not dedicated to Europa, but probably we could provide some technical security profile. Yeah, probably. We have over, just I extend a bit the question. We have over ID, for example, to have how to assess. So we have a standard with a set of requirements. So usually, and we see that now in 6243, when you have a standard with a set of requirements, it's useful to have a technical specification which explains how to assess these requirements with a methodology, with a typical evidence, etc. So it's also one of the ID, and there is on the guidance. We have a lot of ID, but it will depend about the national committee to accept or not this ID.
Also, to your question, we have cleared at the beginning that every agent on ground that receives this energy consumption from TCMS has the trusted that this consumption is from TCMS and not from other EMS. This was the main goal of the standard.
Thank you. Any other question here?
Yes, here. Hello all. We have heard this morning about at least 3 different, let's call it documents. And I'm wondering, in, let's assume, 2 to 3 years, when all of these documents are fully final, published, and let's assume well-known, how do you envision this is going to work for public tenders or for tenders in general, where nowadays, it's like mid 62443, mid 5701, like in general, no more detail. So how do you think 3 documents that are probably going to be playing at the same time, are they going to be used by people who are maybe not so expert as the committees? So how do you think this is going to work in the future?
Maybe I think we heard about the 62443, the 5701, or the new version on the IC level from Search and also from System Pillar, but all of them work together. It's not that these will be contradicting. They are not. The 62443 has a wide range of books, from technical requirements to process requirements to maintenance requirements and so on. Search makes this one more Rails specific in the 63452. So detailing these process requirements, what processes you need to do. And the system pillar writes the technical interoperability requirements on a technical level, the ciphers, the HTTP versions, the TLS versions, the interfaces to how to do time synchronization and so on. So the whole system that we are doing here in Europe and on international level works perfectly together. There's no contradiction actually, because we align constantly. We're talking to each other.
Yes.
Yeah, we make comments to EMS, to telematics, to CCS. The whole rail domain we orchestrate together. So when we look at what happens in tenders, of course, we see generic requirements, but we see also now that the system pillar specification from the technical interoperability at the end, how you need to do it, is referenced already by ULinks. So that's a standard around the interlocking and all the interfaces to object controllers, to TMS and so on. In the latest version, in the summer, they removed their own cybersecurity specification and replaced it with system pillar specifications. We will see this. We have seen this in the telematics. There's already tenders, the big ones in Switzerland and Austria, also using system pillar specification, and they are compatible with the 63452 and the 62443. So you get everything together.
Just to complete, we already, in fact, received some RFP in referring the 63452. The idea also is that it should be possible. The 63452 should be well known. We expect it should be well known and referred, and indeed it's fully compatible and work for that. But before we receive at Alstom some tender where you have just a list of endless and non-compatible requirements. So my expectation is that through dissemination, through training, etc., okay, we have a minimal set of meaningful standard and specification. You can refer it, and that's enough. And you don't. Sometimes we receive a RFP requesting ISO 27001 to be applied on a train, but it's not relevant. So if it is on an organization, not on product. So if we arrive to educate the people issuing, I would say, call for tender to refer the relevant set of standard and specification, I think we make a good progress to fluidify everything. Yeah.
Okay, I think it's time for the break, but we can take one more question. Yeah.
Is working? Yeah. My question is, if all of this documentation, all this standard will be work together, there will be a matching between the three of them? I mean, if they are compatible, then it should be possible to have a matching between them.
What we provided is a tracing table. So we need to understand that the 62443 is on a very generic level.
Yeah.
We have the 63452 from Search that is a Rails-specific interpretation of the 62443. So it's a level down, more detail. And then we go down to the system pillar specification, which is the technical implementation of these things. So it's actually detailing of the requirements. They are not contradicting. We have full traceability. You can find from all the requirements, from all the CRA, from the NIS2, from the 62443, the requirements, and from the 63452 and 5701, a full tracing. So it's completely transparent how these requirements are mapped and how these three standards actually work together. Take a look at the tracing tables, and then you can see how this works.
Okay.
Yeah, I don't think there will be a mapping because the scope are not exactly the same, the targets are not exactly the same. They need to be coordinated in order that they do not contradict and complement. But the 63452 is, I would say, a global standard covering all the railway for all countries, Japanese, Chinese, enfin non-European countries also. And so we need to have agreement with this guy. And the lower detail from the RGU, I would say more technical, is really fit for purpose for Europa. And we wouldn't be able, sometimes people out of Europa are very happy to reuse this kind of spec, for sure. But this is one thing. The other thing is to impose that all over the world, I think is a bit more difficult. But if some technical topic we see from the RGU, which raised, adopted by all over outside of Europa, we can say, okay, this is a good subject to become a standard. And then there is a possibility not to merge, but to standardize part of RGU, technical specification.
Okay, then, so let's go for the break and see you in almost half an hour?
30 minutes.
30 minutes? Okay.